Hi, everyone. Thanks for coming to my talk. So I'm going to discuss running Hadoop on user namespace Docker containers. I'm going to talk about what are user namespace containers and what are Docker containers. I'm going to talk about why at Altiscale we are running with Hadoop deployed on these containers. I'm going to discuss the issues that we've encountered and the future directions that we want to take with this and the future directions of Hadoop and containers in general. First, a little bit about me and Altiscale. So Altiscale is a leading big data cloud services provider. We deploy Hadoop on the cloud on our data centers that and data analysts and other customers can log in and use. We have been running Hadoop on user namespace containers since 2014. I have been with this effort since the beginning, and as part of that, I've contributed to various open source projects, namely Docker, LXC, and with Yarn, I've added the capability of Yarn to launch Docker containers from Yarn, firstly using the Docker container executor, and most recently using the regular Linux container executor. You can now launch Docker containers from Yarn and basically have your tasks wrapped up in your own Docker image and deploy them over a big cluster. But I want to discuss first is what are containers and what are user namespace containers. So as many of you probably know, so in a machine, there are these resources such as file system, network, CPU, and memory. And with a container, you have the capability to carve up parts of that resources for the processes that are running inside the container. So for example, here you have these two containers running, and each can have their own bit of the file system that is isolated for them. And one container cannot see another container's file system. And the same for the CPU and memory allocated to the container. You can say that this part of the CPU and memory is for this container, and this other part is for the other containers, and they will not step on one another's foot. With network, each container can have its own network namespace, and therefore it can have its own IP address. So now, when you're running a process inside this container, you can treat that as if it's running inside a VM or as if it's running inside a machine. It has its own IP address, it has its own file system, its own basically CPU and memory. It's fairly isolated. However, there is one caveat to that isolation. In a Linux machine, there are two types of users, the root user and then the non-root user. The root user on the host has elevated privileges, can see all the processes that are running inside a host, and can affect any process that's running inside the host. It can kill any process. It can look under the proc file system and affect properties of that process. It can change the capabilities of that process. So usually, people run containers as Docker containers as the same root that's running as the host. And this is sometimes needed because you need to, when you're launching the Docker container, you need to do some root-like activities. And that is a valid use case. However, now you're in danger of breaking the isolation that the container is supposed to provide. This root can actually affect processes that are running outside the container. You can change a system-wide property, for example, open files handles, and basically reduce the capability of the system. So how do you get around that? What you actually want to do is still have the capability to do root-like activities inside the container, but this root should not be the root on the host. It should be some regular user that's on the host. So what that allows you to do is this root now does not have the capability to do anything that is outside the host, but it can change and affect root. It can do root-like operations inside the container. And that makes sure that the isolation is maintained and the container can perform its duties, root-like activities without affecting any containers that's also running. So this is what helps a company like Altiscale when we are deploying Hadoop on the cloud on these containers and have on the same machine multiple customers kind of operating on different containers. We want to have this kind of this layer of isolation to make sure that one doesn't affect the other, that one doesn't have the privilege to affect the other. So now I want to discuss why we deploy Hadoop on containers. When we look at a regular Hadoop cluster, so here's one with 2 slave nodes, and the resource manager is talking to the node managers of the slave nodes, and the data node and the name node is talking to the data nodes of the slave nodes. One thing from here that we see is that the node manager and the data node are tied together in one machine, and then they are part of basically the same machine. And so if you want to actually increase the compute available to this cluster, you're going to have to give it another node. And that another node, whatever storage it has, may not be needed by this cluster. So because storage and compute are coupled in a machine, you are wasting storage or wasting compute. And we see this kind of scenario in our data center all the time. Hadoop's compute requirements are very bursty. Customers suddenly require a lot of compute, and suddenly the requirement goes down. So if we have to shuttle in physical nodes in and out of the Hadoop cluster, that's a big problem. So to solve this, what we do is we deploy these NodeManagers and DataNodes in containers. And actually, you could do that. For this particular case, you could do this on VMs also. And as long as they have their own IP address, they can operate as their own slave nodes. The node manager and data nodes are now separate slave nodes. So now you can start giving away them to other clusters. So if you have a second cluster that needs additional compute, you can give away this node manager to that second cluster. And now you actually have additional compute for the second cluster, and your first and second cluster are running on the same machine. One is using all the compute, the other one is using all the storage. So this is a simple kind of an example of how and why we want to deploy Hadoop daemons on containers. So now the next question is, why don't we do this with VMs? Because I mentioned VMs, and they do provide the same isolation, and they've been around longer and therefore are more reliable. And why do we deploy node manager daemons and data node daemons and containers? So to answer that, I want to explain what happens when this node manager actually makes a request to the operating system. So say this node manager is trying to read something, read a file. So it actually has to ask the operating system, which actually tells it where and what device it goes and finds the file. So when that happens, so the node manager and container is making a request, that request directly goes to the operating system kernel. The kernel sees all these requests fairly transparently because the kernel is aware of containers. It is aware of, it actually sees these containers as just as a mapping. So the user inside the node manager requested a file. That gets translated to the kernel as, even if that's the root user inside the container, kernel sees this as a non-root user inside the kernel, outside the container. And the kernel decides, OK, do you have the privilege to see this file? OK, if you do, OK, here you go. Here's the data. So that simple mechanism, because namespaces are inherently supported by the Linux kernel, it's all embedded. And as long as you have a stable kernel, you're guaranteed that containers are going to be supported. With a VM, you are now adding in additional layers. So the node manager now has to talk to the guest operating system of the VM, which will have its own way of forwarding the calls to the hypervisor on the machine. So now the hypervisor has to understand what does the kernel understand and what does the guest operating understand, be the intermediary, and pass through the call all the way to the kernel. And so the issue with having all these layers is if you're actually debugging an issue with the container, which I'm going to dive into a little bit later, you have to understand all these layers and basically manage all these layers to make sure that they always work together well. And this is one of the primary reasons we decided to go with containers, just for the simplicity of the model. And then the secondly, we were aware of the overhead of all these layers, but I'm sure VM technology has matured to a point where these overheads are negligible for the most part. So our main reason was the multiple layers issue with running on VMs. So now that we have established that we're running on containers, now the question is, what does Hadoop actually require from containers? What kind of containers does Hadoop require? So simply put, Hadoop wants containers to act like machines. Hadoop wants containers to act like machines with static IP addresses, and it wants these machines to be able to run multiple processes. So here you can see this is kind of a process tree of things that we're running in one of our node managers. So here we're running the node manager JVM, we're running daemon, NRP daemon, we're running rsyslog, we're running SSH. And all of this have to be running for our node manager to be considered operable. And then to get all of this to run, we're going to have to run a process manager. So we picked init as a process manager. There are alternatives. So why did we pick init? So what we needed to happen was we needed these processes to always start in the same order reliably. So we wanted our operations team to be able to reboot these containers just like they reboot a machine. And then we would want all these processes to be able to start the same way every time. And to guarantee that, you need a process manager who can handle this, who can handle kind of the propagation of responsibilities when, say, one of the child processes parents die, and then who gets the child process, because the child is now, the process is now orphan. So this kind of handling can be done by init, and that was one of the reasons we picked init. So as I mentioned, there are alternatives to init. Supervisor-D was one of the options, and then we also thought of just using the check config utility, having a list of processes there and kind of writing our own tool against it. So it seemed to us that init is more widely supported. Our operations team had a better experience with init, so therefore we decided to go with init. So the next thing that we encountered was init kind of puts its own constraints, and therefore there are some issues when running init in a container. The first issue we encountered was the containers would come up, but there would be no network. We wouldn't be able to access the containers from outside, and from inside the container, we wouldn't be able to go out to the network. So to deal with that issue, we looked at how we are setting up the container. So when we start the container, it starts with its basically init processes inside, and then we get a process ID from the container. We set up an Open vSwitch bridge on the host, and using that process ID and the Open vSwitch, we basically hook up the containers network using something called a vEth pair, which is basically a pipe between two namespaces, the containers namespace and the host namespace. So first, we tackle the issue of not being able to access the container from the outside. Basically, I think that's called ingress in networking terminology. So and to understand that, we actually had to look at how the kind of the state transition of the container as we started. So here's what happens. We start the container, which immediately launches init. In the same time, we are creating the network. what we hope to happen is when we create the network and then we create a pipe between the namespaces, then we have to actually wait for init to give us back a PID, its own PID, and then we use that PID to now attach one part of the pipe to the container, and the other part of the pipe is on the host. So now the container has network. And then we hope that the service that actually needs the network, for example, SSH, which is what we use to log into the container, is operating. However, the ordering that I mentioned here is what we hope to happen, but what you can see from the picture is it is completely, you have to be really lucky for this to happen. What happens is the moment init starts, it goes through the section of init that sets up the network, brings up the interfaces. And at that time, if you don't have network, it basically brings up interfaces without any network. So you don't have a network. And then it rolls over to the stage where it starts up these processes that need network, and they would basically just fail. So now we don't have network. And what we need to do is basically make sure that we have a PID from the container, but we make the container wait to go to the next level before we set up the network to the container. So what we did was, instead of doing docker run init, we created a wrapper process and said docker run, wait for the network to show up. So that's exactly what we did. And we wait for the network to show up. In the meantime, we create the network outside, we create the pipe, and then because we have a PID from this wrapper process that's running inside the container, we can hook this up to the to the container, basically hook up the bridge and the container, and make sure that the container has network. And then we move on to the next step where init sets up the network and launches SSHD and other things that need network. So the next problem is we didn't have network going out from the container. And to understand that, we were looking at, okay, so what's the issue with the routes that this container has in its routing table? So basically, does it have a path to the gateway that it can use to go outside the host? To do that, we basically looked at the routing table. We found out that the gateway entry was missing, or even if it showed up for a while, it got overwritten. So we got around this issue by basically forcing the container to understand that that it needs to get the route, and basically not letting the container proceed before it actually has the gateway properly set up. To do that, basically, what we do, simply put, is from inside the container, we start pinging the gateway at startup. And what that does is it forces the container's NIC to ask for the MAC address of the gateway. And until it gets it, it basically keeps retrying. And once it has the MAC address and can ping the gateway, then it decides, OK, now I have network, now I can proceed. So the next issue that we encountered was cron jobs wouldn't run in a container. So this is a particular issue that happens because we are running this in a deprivileged mode, namely as a user namespace container. So let me dig deeper into what happens when we run a cron job. So in a machine, init starts. This is not in the container. This is outside the container. So init starts. Then that starts cron because that's what we have set up. It's one of the services that it starts. And then cron services job is to periodically launch the jobs that we have that are the cron jobs. So when the cron expression is true, we basically launch the cron job. So say that we have a cron job that is sending metrics. Now, you can configure cron to say that this is being done by a particular non-root user. Or you can configure it to say that this is done by a root user. Either way, there is an audit module called PAM whose job is to basically write down that, OK, this is the user who launched this process. And this is, you can use this to kind of go back and find out, okay, what is this runaway cron job that took away all our memory? Who started it? What happened? And that is done by basically writing inside the proc file system, and that user's UID gets written. And if this PAM auditing doesn't succeed, the process wouldn't start. In a container, to launch a container, we have to launch Docker service. And to launch Docker service, we use Chef. So basically, there's a Chef converge that launches the Docker service. And then here we have an orchestration user that goes ahead and launches the Chef converge. So that orchestration user is now launching Chef converge. What this is doing now is, to PAM module, it seems like this is a user logging in and launching Chef converge. So PAM now starts writing down, okay, this Chef converge was launched by UID 1000. So then that launches Docker. Now PAM starts propagating down this UID. So Docker is launched by also UID 1000. So now Docker daemon, its job is to start the containers. So that container, and actually Docker has a specific property where the shell that starts the container is not the parent of the process. The actual parent of the process is the Docker service. So that UID of the Docker service gets propagated down to init. So init inside the container is now set as something that it was launched by UID 1000. So this is one of the key. This is what the key difference between how it looks in the machine and how it looks in the container. Now, whatever init starts will have the UID 1000. It's because it is getting propagated down. Now, when the cron service actually launches the metrics job, we have two processes trying to write the login UID to the login UID file. And so the propagation process says this was started by UID 1000. And then the send metrics, that is a cron job. So the PAM login UID, the PAM process now tries to write its login UID in there. And it fails because one of the rules in this kernel is that we can only set this login UID if it's unset, because otherwise auditing would be very difficult. If you can constantly override this, you can't really audit based on that. So this fails because it's already set. And PAM says, I can't set the login UID, so your cron job is not going to start. And we have basically none of our cron jobs wouldn't start in the container. So to dig into that, we basically had to trace through what is exactly happening when the login UID is being set. So in the kernel, there's a check basically, can I set the login UID? So what that does is, the first thing it checks is this login UID set? So if the login UID is not set, you can go and set the login UID. You don't have to have any privileges. This is your process, you set the login UID. However, if it's already set, then it goes into first checks, does the kernel overall system-wide give you privilege to override login UID? So this was false for us, so that failed. But even if when we turn that on, there's other checks. So do you have the capability? So in Linux, the root user has these things called capabilities, special capabilities. So do you have the capability to kind of control the audit, modify the audit? So that check fails. And then the next thing that kind of doesn't work is there's a feature to figure out whether we can only set unset login UID. So that also fails. So what we found out is unless the login UID is unset, we wouldn't be able to set it, and so we have to go to the root of the problem and make sure that when containers are started, their login UIDs are unset. So once we found the problem, the solution was fairly simple, and that is to make sure that when the Docker service starts, we treat that is not being started by a login user. That we unset its login UID, and that basically propagates down to the children. And now, because when the cron job inside the container starts, its login UID is unset, so PAM can now easily set the login UID. So now I want to discuss some future directions that we want to take with containers. So I mentioned that in Yarn, now there's a capability to launch Docker containers from Yarn. What that means is user launches these small tasks, and they want to run things like MySQL or an HTTP server inside the container. They want completely isolated environments inside these tasks. And you can do that with Docker if you launch Docker containers. And the question is, can you do that if your node manager daemon is also inside a container? And we ran some experiments with it. This is indeed true. You cannot do it with just the Docker that's right out of just with the Docker daemon. What we had to do is use Docker's kind of the internal library called libcontainer to launch the containers, and that gives us the capability to launch these containers within containers. And you can actually go even farther, because in the kernel, these things are the hierarchical nesting is fairly supported. So if your server, this service that you're running inside the task wants to launch its own Docker containers, you can nest down one level, and you basically can keep going down. And that's my talk. Thank you. And now, if you have questions.
Yeah. Do you have data nodes running in container?
Do I have what? 8?
Data node. I mean, mention of the data node. Do you have data node running in container?
Data nodes are running in a container, yes.
How do you handle storage?
OK, so storage, we basically mount from the host. So the host machines have disks, separate disk devices. We mount them from the host into the container.
So it's data volume, not
data volume. Data volume, yes. Yep.
Thank you.
You mentioned about in a cluster, you're splitting the storage and the compute, and then kind of leveraging across different clusters to kind of let the resources go waste. Otherwise, the resources will go waste.
Yes.
Right? Is there a way that you can leverage within the same cluster, or it has to be leveraged in some other cluster?
So within the same cluster, you can use Yarn's own capabilities to use compute and storage efficiently. The problem we ran into was we were running, because we are providing Hadoop as a service to customers, and these customers don't want to be in the same cluster. Hadoop internally is not yet fully multi-tenant. You can't have Coca-Cola and Pepsi on the same Hadoop cluster. They're just going to not be in your business. So we have separate clusters, and then we still want to share machines, which is where this comes into play. And what we found out is if we don't do this, our utilization of compute goes down to 20%, because we have to, across the data center, we have to over-provision every cluster in a huge way to make sure that in times of need, our customers have the compute they want. Or we have to come up with robots that constantly switch out machines. And what we found out is going the container route is far more efficient to be able to quickly give away the compute when the cluster doesn't need it, and that compute can now be used by other clusters. You first.
Why you have not used Kubernetes?
So good question. So first thing was Kubernetes is, it was fairly immature when we started. It is maturing. And then right now, we're mainly using a flat network for other reasons. With Kubernetes, it sets up the network for you. It's kind of this network orchestrator. And then we are not quite sure how well it interacts with Yarn, because Yarn has its own. So then again, Mesos Yarn integration is also not.
You can then manage Kubernetes, Kubernetes Yarn, on the
Yes, so there's definitely options like that. But the problem that we run into is each framework has its own kind of fairly hard requirements. Mesos, Yarn particularly have completely opposite ideas of how a compute framework should, a data processing framework should work. For example, Yarn decides that it's a monolithic scheduler. It will decide whatever compute particular job needs. Mesos has a completely opposite idea. It says that, okay, the framework will decide whatever it needs. I'm just going to go around and start offering these resources to everybody. So we found out that, yes, if we did a lot of research, it is probably possible we could come up with a solution with that. But for a first approximation, it is easier for us to just come up with our kind of a simpler solution that, okay, what is the requirement for compute across the data center? Can we shuffle around? And with this implementation, we now kind of liberate the compute and storage and give away the compute as needed.
And where are these Docker containers repository?
So that we had to architect also. Basically, we made sure that every data center has one registry and several mirrors of the registry, and then all the images exist in each data center has all the images. We don't have very many images right now.
And what was the OS you used?
Yes, it's CentOS 6.
What kind of effective latency do you see between getting a request and when you create a container, spin up Yarn, have Yarn recognize it, and then you launch the job?
So that's a very quick question. I'm going to come back to you just after this. So launching a container by itself is still fairly fast. We haven't really measured that part because in our orchestration model, that is not a bottleneck. To make Yarn recognize the node manager, I would say it's in order of a few seconds. Basically, you have to change its include and exclude files and refresh the resource manager. That's not even a restart. At this point, we have some other bottlenecks on basically making sure that the entire cluster is consistent with this newly generated container, this newly added node. So that consistency part we're still working on resolving. I'm sure we're going to run into this latency issue eventually. But right now, the straight answer is we are seeing latency in terms of minutes to take for the whole thing to happen. So we didn't get to the point where we are going to tinker with the individual issues like how to start start the Docker container fast and things like that. I will say though that the model that we are using right now, kind of wait for the network to show up, that has a problem. There is a far nicer model to launch containers with network. Basically, you can have the container either invoke a hook on the host saying that I have started, now set up my network, I'm going to wait till the network is set up, then I'm going to go and launch init or whatever you want me to launch. So that is kind of recent capabilities in Docker. Well, not in Docker, basically in libcontainer. And then you can also have a model where you create the namespaces first, and then you do whatever you need to do on the host, put the networking configuration in the namespace, then you launch the container. We may go with either of those models as we move on. You had a question.
Yeah, I had a similar question. So you do not use resource and KS to manage your resource, right?
No.
So how do you, but you still need to manage your container resource in the network.
Yes.
So what's the mechanism you use? You just use the configuration you set up?
So the way we manage resources is fairly simple right now. So we have this, we treat this as kind of a resource distribution problem. So clusters tell us whether they need additional resources or they can give up additional resources. The yarn you can kind of expose its metrics to Kafka. And we're processing this Kafka stream that comes in from each cluster. And it tells us, OK, I have this much pending memory. I have this much pending CPU. So that means that there are jobs submitted on the queues that are needed to kind of satisfy this cluster. And if we don't do that, the jobs will incur more latency than they are doing now. So we analyze that. We figure out whether we can actually satisfy that demand. So we have a pool of resources on the data center that we look at, and we call it the inventory. So we first see if we can give away resources from this inventory. Then we look at, OK, are there other clusters that are willing to give away resources? Can we give away that? So this is kind of a cost optimization problem that we have come up with. And we try to resolve that for across the data center to kind of optimize on certain things, such as if the clusters are we able to reduce the job finish times for all our customers? Are we able to reduce the container, the wait, the queue time of the jobs, the amount of time they wait in the queue for the jobs?
So how big a cluster do you have?
So we have separate clusters. So some clusters have about, I guess, 40 to 80 nodes. Some overall total across the data centers, we have 1,000 nodes. Well, actually, I gave you the count of machines. Containers would be more, yeah.
Oh, you mean 1,000 machines? So
yes.
Machine probably have 8 to 10 containers.
For us, at this point, we have only 2 containers per machine. Yes. Well, one has all of the compute, the other has all of the storage.
Question about the storage, following up on question about storage.
Yes.
If you have multiple name nodes running on the same physical machine,
Mm-hmm.
they have 2 separate disks, or is it the same physical storage that you share between them?
So at this point, we are not running, we're only containerizing the slave nodes, not the name node. But to answer your question, if we do that, we will have separate disk devices per name node to make sure that they basically completely separate storage, to make sure that the noisy neighbor problem is avoided as much as possible.
So your data, when you create new containers, your data is not copied into the local disk space of the container.
It's in a volume. Yes, they're always in volumes. And main reason we do that is because the disk devices are not affected as much as, basically they're more isolated when you read and write from them, versus when they're all on the same disk device on the machine. So then isolating them is a little bit more difficult. You kind of have to play with C groups to say, OK, this guy gets this much CPU and memory, and this guy gets this much. and you have to make sure that somebody doesn't write some very clever I/O intensive program that will basically circumvent all your guards and make the other, basically the neighbor in that this device really slow.
To use the volumes, then does it require you to start containers in rich mode or in
Good question. No. So initially it did, but user namespaces, you can, if you bind mount the directories under the volumes and basically just treat them as directories, you can start user namespace containers and have the bind mount kind of act as this transparent pipe between the namespaces. You don't have to. Now, if you want to basically create devices, basically make a make node call from the container, yes, you need privilege mode. We're not doing that at this point.
So thank you everyone for your questions. That was a great talk. Let's give them another round of applause.
Thank you. Thank you all for coming.